Alright, so in this problem, I have 4 to the power of x is equal to 8. So I want to find the value of x. For my solution, first start with 4 to the power of x is equal to 8. And 4, this is the same thing as 2 to the power of 2. And 8, this is the same thing as 2 to the power of 3. So now if I replace 4 with 2 to the power of 2, and if I replace 8 with 2 to the power of 3, I get 2 to the power of 2 to the power of x is equal to 2 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is simply equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x, which is simply 2x, which is equal to 2 to the power of 3. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, 2x is equal to 3. So I have 2x is equal to 3, so I'm simply going to divide both sides by 2. These two cancel out, and I'll be left with x is equal to 3 over 2. So this is my answer. Now, there's actually a second method of solving this problem. So again, I first start with 4 to the power of x is equal to 8. But this time, I'm going to take the log on both sides. So now I have log 4 to the power of x is equal to log 8. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So in this case, for log 4 to the power of x, I can move x to the front. So that's going to equal x times log 4, which is equal to log 8. Now I can simply divide both sides by log 4. These two cancel out, and I'll be left with x is equal to log 8 over log 4. Now, remember 8, that's equal to 2 to the power of 3, and 4 is equal to 2 to the power of 2. So now I have log 2 to the power of 3 over log 2 to the power of 2. Now I can move these exponents to the front. So now I have x is equal to 3 times log 2 over 2 times log 2. These two log 2's can cancel out, so I'll simply be left with x is equal to 3 over 2. So this is my answer. Alright, so for this problem, I have x is equal to x over 2. So I want to find the value of x here. So for my solution, first start with x is equal to x over 2. Now I'm actually going to subtract x over 2 on both sides. So then these two x over 2's cancel out, and now I'll be left with x minus x over 2 is equal to 0. Now I'm going to multiply both sides by 2. So now I have x minus x over 2 times 2 is equal to 2 times 0. So for 2 times x minus x over 2, I'm simply going to distribute the 2 to all terms in my parentheses here. So first off, 2 times x, that's simply equal to 2x, and 2 times negative x over 2, the 2 simply cancel out, so I'll be left with is negative x. And this is equal to 2 times 0, which is simply equal to 0. So I have 2x minus x is equal to 0. Now 2x minus x, that's simply equal to x. So I have x is equal to 0. So x equals 0 is my solution. Now I actually have a second method of solving this problem. So again, I first start off with x is equal to x over 2. And now this time, instead of subtracting x over 2 on both sides, I'm actually going to multiply 2 on both sides. So I have 2 times x is equal to x over 2 times 2. Well, 2 times x is simply equal to 2x, and x over 2 times 2, these two 2's cancel out, so I'll simply be left with x. So I have 2x is equal to x. Now, I'm going to subtract x on both sides. These two cancel out, and I'll be left with 2x minus x, which is x, is equal to, on my right-hand side, I'll have 0. So x equals 0 again. So now to check, I have x is equal to x over 2. We know that x equals 0. So I have 0 is equal to 0 over 2. 0 divided by 2 is 0. So I have 0 equals 0. And because this is right, my solution is right. Alright guys, so in this problem, I have 2 to the power of 20 minus 4. So I'm going to first start by rewriting 2 to the power of 20 as 2 to the power of 10 times 2. So I have 2 to the power of 10 times 2 minus 4. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2, we can rewrite as 2 to the power of 10 to the power of 2. Now I have this minus 4. 2 to the power of 10, that's equal to 1024. So now I have 1024 to the power of 2 minus 4. And 1024 I can rewrite as 1000 plus 24. So now I have 1000 plus 24 to the power of 2 minus 4. Now if I have something in the form a plus b squared, this is equal to a squared plus 2ab plus b squared. In this case, a is equal to 1000 and b is equal to 24. So I have 1000 squared plus 2 times 1000 times 24 plus 24 squared. And then I have my minus 4 at the end. Now 1000 squared is equal to 1 million. 2 times 1000 is 2000. 2000 times 24 is going to be 48,000. Now 24 squared, that's going to equal 576. So I have 576 minus 4. And 576 minus 4 is 572. So I have 1 million plus 48,000 plus 572. And this is equal to 1,048,572. So this is my answer. Alright, so in this problem, I have 3 to the power of x times 5 to the power of x squared is equal to 15. So now the first thing I'm going to do is divide both sides by 5. So now I have 3 to the power of x times 5 to the power of x squared over 5 is equal to 15 divided by 5, which is 3. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, 5 is the same thing as 5 to the power of 1, and 5 to the power of x squared over 5 to the power of 1, that's going to equal 5 to the power of x squared minus 1, which is equal to 3. And now I'm going to divide both sides by 3 to the power of x. So then these two cancel out, and 3 to the power of 1 over 3 to the power of x, that's the same thing as 3 to the power of 1 minus x. Now, if I take the log on both sides, I get log 5 to the power of x squared minus 1 is equal to log 3 to the power of 1 minus x. And if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this can equal b times log a. So in this case, I have x squared minus 1 times log 5 is equal to 1 minus x times log 3. Now, if I divide both sides by log 5, I get x squared minus 1 times log base 5 of 5 is equal to 1 minus x times log base 5 of 3. So if you divide two logarithms, the logarithm that's being divided by, that's going to turn into the base. Now log base of 5, that's obviously equal to 1. So now I have x squared minus 1 is equal to 1 minus x times log base 5 of 3. And now if I subtract 1 minus x times log base 5 of 3 on both sides, these two cancel out, and I get x squared minus 1 minus 1 minus x times log base 5 of 3 is equal to 0. And now x squared minus 1, this is the same thing as x squared minus 1 squared, which is the same thing as x plus 1 times x minus 1. So I have this minus 1 minus x times log base 5 of 3 is equal to 0. And now if I factor out x minus 1, I get x minus 1 times x plus 1 plus log base 5 of 3 is equal to 0. So now this gives me two equations. I have x minus 1 equals 0, meaning x is equal to 1, and I have x plus 1 plus log base 5 of 3 is equal to 0, which means that x is equal to -1 minus log base 5 of 3. So these are my two solutions. Alright, so in this problem, I have x to the power of 4 minus 16 is equal to 0. So what I'm first going to do is I'm going to rewrite x to the power of 4 as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, that's going to equal x to the power of 2 to the power of 2. Now I have this minus 16, which is the same thing as 4 to the power of 2, is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 4. So I have x squared plus 4 times x squared minus 4 is equal to 0. So now this gives me two equations. I have x squared plus 4 is equal to 0, and I have x squared minus 4 is equal to 0. So for x squared minus 4 equals 0, I'm going to write 4 here as 2 squared. So now I have x squared minus 2 squared is equal to 0. Now remember that if we have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And in this case, a is equal to x and b is equal to 2. So I have x plus 2 times x minus 2 is equal to 0. So now this, again, gives me two equations. I have x plus 2 equals 0, and I have x minus 2 equals 0. So for x plus 2 equals 0, x equals -2, and for x minus 2 equals 0, x equals +2. So these are two solutions of x. Now for x squared plus 4 equals 0, I'm going to subtract 4 on both sides. These two cancel out, and I have x squared is equal to -4. Now I'm going to take the square root on both sides. Square root of x squared is x, and the square root of -4, that's the same thing as square root of 4 times the square root of -1. The square root of 4 is 2, and if you guys already know, the square root of -1 is I. So I have x is equal to positive or -2i. So these are another two solutions. Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now I'm going to rewrite 6 here as 3 times 2. So now I have x to the power of 3 times 2 minus x to the power of 3 minus 2 is equal to 0. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 2, that's going to equal x to the power of 3 to the power of 2. Now I have this minus x to the power of 3 minus 2 is equal to 0. Now I'm going to let x to the power of 3 equal y. So now I have y squared minus y minus 2 is equal to 0. Now, to solve this, I'm actually going to factor this out. So y squared minus y minus 2, this is the same thing as y squared minus 2y plus y minus 2, because negative 2y plus y, that's negative y. And now if I factor out y, I get y times y minus 2 plus 1 times y minus 2 is equal to 0. Now if I factor out y minus 2, I have y minus 2 times y plus 1 is equal to 0. So meaning y is equal to either 2 or negative 1. Now remember how we set x to the power of 3 equal to y. So now I have x to the power of 3 is equal to 2, and I have x to the power of 3 is equal to negative 1. So first off, for x to the power of 3 is equal to negative 1, I'm actually going to start by adding 1 on both sides. So I have x to the power of 3 plus 1 is equal to 0. Now this is the same thing as x plus 1 times x squared minus x plus 1 is equal to 0. And this gives me two equations. I have x plus 1 is equal to 0, meaning x is equal to negative 1. So this is one solution of x. And I have x squared minus x plus 1 is equal to 0. And if you actually go ahead and plug this into the quadratic formula, I'm actually not going to waste your guys' time and do that. You should get 1 plus or minus the square root of the square root of 3i over 2. So these are two more solutions of x. Now, right here, I have x to the power of 3 equals 2. This is pretty straightforward. All I have to do is take the cube root on both sides. So I have the cube root of x to the power of 3 is equal to the cube root of 2. The cube root of x to the power of 3 is x, and the cube root of 2, that's simply, we just keep it in that form. So I have x is equal to the cube root of 2.